Happy e-learning day. All right, so today we are going to go over how the atomic model has changed since 400 BCE, that is before Common Era. So we've been drilling over protons, neutrons, and electrons these past couple weeks, and so we're going to see how our recent modern understanding of the atom is really only about 100 years old, and it's taken a long time to get to this point. So we're going to go through some of those earlier models today. Just a quick recap, atoms are the smallest complete unit of any chemical element. So if I want to say hydrogen, I can't be hydrogen and get any smaller than one atom of hydrogen. And then each of these atoms are made out of protons, neutrons, which make up the nucleus, and the electrons, which orbit around it. Atoms are built of a nucleus that is orbited by electrons. So we go past that, and we are going to go over our first model. So circa 400 BCE, we had this dude called Democritus, who was Greek, and he was the first person to actually use the term atom. If I can write it, there we go. And what he thought was that they were these indivisible, you couldn't divide them, objects that made a substance, and they couldn't make any other substance. So for example, water was made out of these little circles, and the circles would come together. And then if you wanted to make iron, they were like these little burrs that connected and grinded into each other. And so basically, as the substance changed, he thought the appearance of the atom changed. And that's partially correct and partially incorrect. So as we get further into chemistry, we'll see really what we can take away from this. Basically, the only thing we can take away is that every substance we see is made out of smaller particles. So he had that much right. But they can rearrange to form almost anything, and atoms are not just one type of thing that make up substance. Water is made out of, for example, two different atoms, hydrogen and oxygen. So he was incorrect on that front. Then we get to Dalton. So Dalton didn't come around until 1803 Common Era. So we had about 2,200 years between Democritus and Dalton. So what he thought the atoms looked like were spheres, and each sphere had its own mass. So atoms aren't necessarily spheres, but he was the first person to give them each their different mass units. So here were the elements that he assigned masses to back in 1803 in this picture right here. And so what we know now is that we have different types of atoms, but atoms of an element don't have to be identical, hence isotopes. So we just went over how you can be a nitrogen atom but have different masses. So he was on the right track, but not completely correct. Okay, then in 1897, so almost 100 years later, we had Marie Curie. She was the first person to figure out that atoms could change into other atoms if they were unstable, which is called radioactivity. So anything that's less stable is going to decay or turn into something that is more stable. So, and sometimes when that happens, you have some sort of radiation, okay? So the radiation could actually be physically radiant, it could actually be light, or it could be a different type of radiation that you can't necessarily see. So there's several types of decay. We will actually go over 3 of them, but what we know now is that we do have different types of atoms, and not all of them are equally stable. So if you're unstable, you can change into a different atom or a different element, okay? Thomson. So Thomson, he's quite a guy. Saucy little minx. He came around in 1904, and so with the Plum pudding model, and what he thought was that we had this sphere that was an atom. So here's what an atom was, and he thought that the protons and the electrons were intermixed. So he thought the electrons were like these plums in plum pudding. If you've ever had plum pudding, it is what is in the background. So basically, it's like this large bowl of bread pudding with plums in it. So the plums represent the electrons that were intermixed within a positive sphere. What he had right was that we had protons and electrons going on. What he had wrong was that the electrons aren't inside the positive charge. They're outside of it. Okay? So electrons are not in the center of the atom like he thought. Then in 1905, we had Einstein. So he was the first person to figure out that the energy of an atom was directly correlated to its mass. So the larger or more massive an atom you had, the more energy it would have. So he is responsible for the theory of relativity, and that was able to prompt basically the creation of the atomic bomb. Now the atomic bomb was uranium, and so that was quite a massive atom, which is why it released so much energy in the explosion. Because since it was one of our largest atoms on the periodic table, it had more energy to release when the atom was split. So what we know now is that splitting an atom of substantial mass releases a lot of energy. All right, then we got Rutherford. So Rutherford came around in 1911, and he was the guy who figured out that the nucleus was positively charged and it was orbited by negative electrons. So he was the guy who fixed Thomson's theory, because Thomson thought that the electrons were in the middle. But Rutherford came out and he's like, hey, these are actually outside the atom. So how did he do this? He took an alpha ray, which is this positively charged ray, and he shot it at a gold foil screen. So here comes let's do like a little highlighter. So he's going to shoot this ray at a gold screen, and the ray is full of these little positive charges. And as he shoots it at the gold screen, it goes through some regions of the foil, but bounced back from others. So what he saw was that it went through the foil in one spot, but then it bounced back around it. And so what he realized was that the spot where the ray went through the foil was an opposite charge. So basically, where it went through, the protons were being attracted to the negative electrons. And what happens in magnetism is when you meet something of the same charge, you're going to bounce back. So all the spots where it went through, I'm going to draw it going through and maybe like another spot. Whoops, wrong one. All the spots where it went through the foil was where it was hitting the electrons surrounding the atoms that made up the gold foil. But all the spots where it bounced back were where it was hitting the positive nucleus, because when a positive meets a positive, or a negative meets a negative, in magnetism, they don't mix. They bounce back. They bounce back off of each other. They reflect. So here's another diagram. So Thomson, he thought that all the negatives were in the middle of the atom. Okay? But if that was true, we wouldn't have any rays bounce back like Rutherford had. Because he had it bounce back, he hit the positively charged nucleus because it's all protons and neutrons. Whereas when he went through it, he was being attracted to the positive ray, was being attracted to the negative electrons and allowed to pass through the atom's boundaries. So what did he figure out? Long story short, the nucleus is positive, the electrons are on the outside. Bohr came out and he built off of Rutherford's model. Not only now did we know electrons were on the outside of the atom, but we also knew that they were in different layers around the atom, which are called subshells. And subshells have different energies. We'll actually be doing these here in a few weeks, where we orient the electrons on certain layers. And each layer or subshell can only hold a certain maximum amount of electrons. So what's the big deal here? What do you find out? We know that electrons by now are on the outside of the atom. But what he told us was that they're in different energy levels or subshells of the atom. Okay, so they're not all in just one circle like we've been diagramming. And the other thing is that they're not all just, they're on different layers, they're not all circles either. It's actually quite complex in real life, which is where this model comes in. So Schrodinger comes along, he's our second to last guy, and he figured out that electrons how they move, basically. So they don't just go in a circle like this, okay? Or they don't just kind of like zigzag around the atom. What they do is they have a very frenetic pattern, which I'll use a computer simulation to diagram. But basically, the electron moves very, very quickly. And as it spins, the electron is spinning in one direction. So let's say this one is going counterclockwise. And then the electron over here is going to be going clockwise. And as they spin, they basically make this like wave. They make this wave as they go through their level. Okay, so basically, what did he show us? He showed us that electrons move very quickly, and they move in waves. And because they move very quickly and they move in waves, we can't actually ever pinpoint their exact location. So we have a cloud. So if I get rid of this, we see a formation of clouds here. And that shows us all the possible locations where an electron could be at any given instant in time. So because electrons move so fast and they're so hard to track, we have a cloud model that helps us estimate their approximate zone of location. Okay? So it's like, we don't know where they're at, so where's the area where they could be? That's what he did. Okay? Now, Chadwick is our last guy, and if you think about it, we've talked about everything in the atom so far except the neutron. So he kind of did what Rutherford did. He hit a beryllium atom, atom number 4, with a positive ray. And the ray made radiation without a charge. So when he hit the ray against the beryllium, it made this radiation, and there was no positive, there was no negative. And then it went through some paraffin wax, and then it made a positive charge. So he was like, well, what's the deal here? There's no charge here. So he realized that he was filtering out the neutrons out of the atomic nucleus. Okay? So basically, he realized that in an atom's mass, it wasn't just protons. There was some other thing in there that didn't have a charge. So he came up with the term neutron, and that was 1932. So that's our understanding of the atom. Where did we get to? First of all, we started in 400 BCE. Democritus thought atoms were these little building blocks. He was right, and that was about all he was right on. And then we got to atoms having different masses. Then they have positive charges, then they have negative charges, and then we had to figure out where the negative charges were. And then we also ended up finding out that there's neutral charges as well, which takes us to where we are today. So I'm going to have a couple questions on these models, and then you guys just have to answer these, and I hope you have a great day.